Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Wheels Tessellation by Alaric Taki A, otherwise known as Crusader 175. And here are the rules. We have tessellation, which means fill each cell with a digit from 1 through 9. And cells sharing an edge can't have the same digit. So if for whatever digit is in this cell cannot be shared in the 8 cells that share an edge with it. And each horizontal row and vertical column contains a non-repeating consecutive set of digits, like 2, 3, 4, 5, 6. So those could be like 2, 3, 6, 5, and 4 in any order, right? So that would be valid for this horizontal row. And the special rule here is wheels, where digits in a gray circle have to be placed in the same circular order in the 4 cells that are touched by the circle. The circles might have to be rotated to the correct position by 90, 180, or 270 degrees. So, in basically, you could have something like 5, 6, and 8, and that would satisfy this wheel. Or it could be 5, 6, and 8 here. But you have to have this relationship of the 8 being, the 6 being clockwise from 5, which is being clockwise, the 6 being clockwise from 5, and the 8 being clockwise from 6. So you could have, again, you could have 6, 5, and 8. That would be valid because the 6 is clockwise from 5. The 8 again is clockwise from 6. And the last possibility would be 5, 6, or 8 here. And that's an example of how wheels work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's see. So 2 and 8, okay, so 2 and 8 cannot be in these cells here, because if 2 and 8 are here, and they have to be opposite each other, then this doesn't form a rem band, right? 2 can only form a rem band with 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. 8 can only form a rem band with 4, 5, 6, 7, 8, and 5, 6, 7, 8, 9, none of which contain a 2. So therefore, this must be a 2-8 pair here. And 3 has to be one of these 2 digits. Since this is a 2-8 pair, the remaining digits in this row have to be 3 through 7. And 3 cannot be here because of the 3. One of these 2 has to be 3. So this is 3 through 7 here. Okay. 4 and 7 can work either way here, so that's fine. 5 and 9 could actually work either way here, so that could be fine. 5 and 8. So we know this could be 5. So if this is 5, so 8 is one of these 3. So since 8 is one of those 3, 6 has to be one of those 3, which means 5 is one of these 3 here. Okay, so this cannot be, well, it could be 5 technically. Could it? No, because one of these 3 is guaranteed to be 5. So this could not be 6, and this can't be 8. We already know that. Um. Hmm. Hmm. So this can never. Okay, this always has to have a 3. So then this is 1 through 7 here. Okay, this cannot be 2. Um, this cannot. This 1, 2, 4, 5, 6, 7. So this has to be. If this is 2, that means this is 3. So this has to be 3 guaranteed here with 1 or 4. If this is 8, we have 7 guaranteed here with 6 or 9. But that doesn't tell us too much. Hmm. 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 We obviously know 3 has to be one of these 4 digits. That doesn't tell us much. Hmm. Hmm. Um. Hmm. So if 1 is on either side here, this must be 1, 2, 3, 4, 5. So then this would be 4 and 7 in some order. So how would that work? So this one of these would be 1. This could not be 1. Could not be 4. So it's 2, 3, 5. Um, this could be 5 and 9, and that could work. Phew. 5 and 9. 5, 6, and 8. Um, oh, okay. If we have 5 and 8 here, in some sort. 6 has to be one of those two. Then this can never be 3 because it's 4 through 8 or 5 through 9 here. So this would have to be 3. Which would mean this is 3. So clockwise would be 2. This would be 8. So this could not be 8 if this was a 5-8 pair. That's interesting. Ah, interesting. So another thing we know, if this is 8, 3, and 2. So if this is 2, this is 3. So this can never be 3, which means this can never be 1. So this would be 2, 1, 3 if that were the case. Oh, no, this can't be. So it can't be 2, 1, 3. Because this is sharing an edge with that, too. So if this is 2, 3, and 8, that doesn't work. So this must be 8, 3, and 2 that way. This cannot be 3. This has to be 6, 7, and 9 with 7 guaranteed here. That means this can't be 7 because it shares an edge with both of these two cells. This is 3, so this cannot be 5 and 8. So therefore this must be 5 and that's 8 and this is 6. Okay. That means 5 cannot be here or here or here. This can't be 6 because of the 6 sharing an edge. This is 5 and 8 here. So 5 cannot be here. 5 can be any of these cells. That means 9 can be any of these cells, and 7 can be any of these cells. Okay. This is 8. 6 cannot be either of these, so this must be 7, 9 as a pair. That means this cannot be 7, 8, 9, or 6. This is 1 through 5. This cannot be 8 here. Well, you can't have 8. It's 3 and 6. We cannot have a 5 here. We need a 5 on this row, so this must be 5 here. 2 and 9 cannot form a rem band that's 7 in length. So this is 7, that's 9. Therefore, this is 2, 5, 7. 7 cannot be along here. This must be a 4, 7 pair here. So this is 4, 7, 4, 7, which means this can't be 7 here, which means 7 has to be one of these two digits, which means this cannot be 5 and this cannot be 9. This is a 5, 9 pair. So we have a 5, 9 pair. That means, and 7 is one of these two, so 7 cannot be here. This is a 4, 7 pair here. 4 cannot be here because a 5-length rem band with a 9 never can have a 4. So this is 7, that's 4. None of these can be 7. So, and this is fine. This cannot be 3 or 4 because of the red band 5 and 9. So this is 6. This can't be 6, no 6. This has to be 8. Okay. This can never be 9 because 4 and 7 can't have a 5-length rem band with 9. So this is 5, which makes this 9. So this is 9, then 7, then 5 to be in the proper order. 8, 6, 5, 8, 3, 2. This is 4, 7. One of these is a 1. So then we have remaining digits in this column are 1, 3, 4, and 6. None of these could be 4 because they share an edge with 4, 7 as a pair, so this must be 4, which eliminates 4 here. So we have 1, 3, 6 here. This can't be 1. This is 3 or 6. This cannot be 8, so it cannot be 4, 5, 6, 7, 8. So this is 3 or 6 here. 9, 7, 5. None of these could be 7. We need a 7 guaranteed in this 3-length rem band. So this is 7. This is 6 or 9. We cannot have a 1 on a 7-length RAM band starting with 8 because the minimum is 2. So this can't be 1. This can't be 1. That means we have a 4-7 pair in column 3, which means this has to be 5 and 6 remaining. And this 5-6 pair eliminates 6 in the rest that in the cells that share an edge with it. This can't be 6, that's 9. This can't be 6, so it's 3, which makes this 6, which makes that 1. This must be, so this 9, well, we already knew that. This is 3 through 9 here, so it's 4, 5, 6 remaining. This can't be 6, this can't be 5, because of the 5 in the 6 eliminates 6 here, so it's 3. This must be 1, 2, 3, and this can't be 3, so this is 2, this is 3. That leaves this digit as a 6, which means this can't be 6, that's 5 and 6. This is a 1 here, so to be in order, it has to be 7, 1, and 4, which makes this 5. 6 eliminates 6 here, so it's 4, which makes that 3. This can't be 5, so it has to be 2, 3, and 4. This 7 eliminates 7 here, so it's 4. This can't be 3 or 4, so it's 7. This can't be 3, 4, or 5. It's 1 or 2. 1 or 2 cannot be here. 2 cannot be here because they share an edge here. They share a row, so this must be 2 here. And what are we looking for? 1 and 8. 1 can't be here because of shares an edge with that cell, so this is 8. That's 1. Now we have 3, which cannot be here, so that's 8, which makes that 3. And that's a solution. Yeah, pretty straightforward. I didn't really get the wheel here correct. So that was interesting, actually. But yeah, everything flows from that. I've never done anything like these wheel things, so that's kind of interesting. You could probably use that in normal Sudoku, too. Possibly. Yeah, I mean, I don't see why not. Yeah, I mean, it might be something that you could probably use in normal Sudoku, and I think it might actually work fairly well. Maybe not. That's hard to say. There's definitely some unique aspects of the tessellations which force this to be certain ways. But anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.